In the previous video, we have seen how a transportation problem looks like. So now let's talk about a balanced transportation problem. In the balanced transportation problem, we have the total number of supply exactly the same with the total number of demand. And if we look at the example in the previous video, the power core example, that is the case. We have the supply, the total supply of 125 million kilowatt hours, and the total demand for all cities is also 125 kilowatt hours. If that is the case, the total supply for all supply points is the same with the total demand for all demand points. It means that we will have equality in the supply constraints and equality in the demand constraints, which means that each supply point will supply exactly as much as its capacity, and each demand point will receive exactly as much as its demand. And why this balanced transportation problem is preferable? Because if you have a balanced transportation problem, then it is simple to find the optimal solution. So the importance of balanced transportation problem is because once we have a balanced problem, then it is simple to find the optimal solution. But in general, sometimes we do not have a balanced transportation problem. In general, what we have is that whatever we send from one supply point must be less than or equal to its production capacity or supply capacity, and whatever a demand point receive must be greater than or equal to the demand. So it does not have to be exactly equal generally. So in this case, we have a general transportation problem, and this is kind of harder to solve. That's why we are always going to convert this kind of problem into a balanced transportation problem. Next, we are going to see how can we convert a general transportation problem into a balanced transportation problem. The first possibility is that the total supply exceeds the total demand. In this example, we have 3 supply points, and then if you take the sum of their supply capacity, the total is 125. We have 4 demand points, but if you take the demand for all these 4 cities, the sum is only 120. It means that we have more supply than the demand. What we can do to balance this problem is to add dummy demand, right? Because demand less than supply, so let's just adding a dummy demand. So dummy demand is something that does not exist in the reality. It's not a city, it's not anything. It's just a dummy point that will help us through the calculation to make the calculation simpler and easier. Okay. So we add a dummy demand here. We can call it a dummy city 5, for example, with the demand equals 5. So now the total supply capacity that you have becomes equal to the total demand for all the demand points, including the dummy city 5. And then you may wonder what is the cost from sending electricity from any of these plants to the dummy city. In this example, we can set the cost equals 0, but it really depends on the problem. Because you may think of this dummy city 5 is the excess of the capacity that we don't use from any of this plant. If there is a penalty because we have more capacity than we need in the supply points, then maybe that penalty can be used to reflect the cost. But if it's okay to have more supply than the demand and there's no consequence from the cost side, then you can just say that the cost of shipping from any plant to the dummy point equals 0. But again, be careful, this really depends on the problem that you are facing. The other possibility is the other way, if our total supply is less than the total demand. When we do not have enough supply capacity to fulfill the demand, this problem is actually infeasible, right? Because there's just no way to produce what the demand point wants, okay? So the problem is actually infeasible unless the unmet demand or the unsatisfied demand is allowable. Usually in this kind of problem, the demand is allowed to be unsatisfied, but there is a penalty for doing that or for not satisfying the demand. Let's see an example of this kind of problem. In this example, we have two reservoirs that supply water to 3 cities. Each reservoir can supply up to 50 million gallons of water per day. So the total supply that we have is 100 million gallons. And each city would like to receive 40 million gallons per day. So we have 3 cities. The total demand for 3 cities is 3 times 40 equals 120 million gallons of water per day. The supply is only 100, the demand is 120. So clearly there will be unsatisfied demand. It says here that for each million gallons per day of unmet demand, there is a penalty. For City 1, the penalty is $20, City 2, $22, and City 3, $23. And the cost of transporting 1 million gallons of water from each reservoir to each of the city is shown on the table. And we would like to formulate the problem that can be used to minimize the sum of shortage and transport costs. So transport costs come from this table, and the shortage costs come from the fact that we cannot satisfy all the demands because the supply that we have is only 100 million gallons, but the demand is 120 million gallons. So our original supply is only 100 million gallons. Our demand is 120 million gallons. So we have less supply than demand. To make things balance between the supply and the demand, we just add a dummy supply point. So we are adding 20 million gallons. So now our supply capacity becomes 120, including the dummy. But remember, the dummy point is just something that does not exist. So that's why the cost of sending the water from dummy to each city, the cost here is the penalty of shortage of the demand that can be met from the real reservoir. For example, if we have this kind of solution, again, we have not talking about how we can get the solution, okay? So we just assume that we have a solution that looks like this, okay? So assume that we have a solution saying that we are going to send 20 million gallons of water from dummy point to city 1. Because dummy point is actually something that does not exist, so this 20 million gallons is actually, they're not water, they're just nothing. Or in other words, the city 1 experienced the shortage of 20 million gallons of water, okay? Whatever sent from the reservoir, they are real water, but whatever sent from the dummy is, they're just nothing because dummy is just nothing. So whatever appears here on the last row reflects the shortage or the demand that cannot be satisfied from the real reservoir. Okay, so to summarize what we have been talking about in this video, if you have less demand, then you can just add the dummy point. If you have less supply than the demand, then you just add the dummy supply point. and why we need to make the problem balance, because the balanced transportation problem is easier to solve. Okay, so that's all for this video, and see you on the next one. Thank you.